Yeah, I asked Tara to allow me to do a real quick thing, maybe 5 minutes. How many people here have been a member for more than 2 years? Okay. Been a member more than 2 years. Yeah, you've been a member for a lot more than 2 years. Yeah. Okay, keep your hands up. Now, how many of you have a basic understanding of Excel? Okay, that's good. That's good. Okay, that's good.
Excel.
Yeah, that's fine. That's fine. Now, all of you people are qualified. Of course, for what, you might ask, but I'll get to that in a minute. Now, if you look at the last page of every newsletter, anybody seen this page? On the last page of the newsletter, you're going to see a bunch of our members who serve different roles for the club. And these are very dedicated people, and they are all helping keep the club vibrant, interesting, and growing. So, like Kent here, who does the What's Up for these, Ken Coates and Ken DeSilva, who are longtime outreach coordinators. We've got Jeff Adkins, who's our brand new speaker getter for the speakers here. And of course, Tara, who's been serving as president for a few years now. And Marianne, who is the one who makes sure that we have refreshments out here at every single meeting. So as a member, I hope you realize you have the opportunity to take on one of these roles and get your name in the newsletter. Mainly because a lot of these folks have been in that position for a long time, and a lot of them want to pass the torch. Sorry? Oh, and so now, for example, Marianne is absolutely willing to continue to do refreshments, but she needs one or two people to help her, trade out, like do a few months and then somebody else does it for the next few months and so on. So go talk to Marianne at the break. It's a relatively simple task. She'll tell you all about it. And then here's the important one. Beth Rainsford has been serving as our treasurer for right around 10 years. And that's a long time. And she says it's time to pass the checkbook. So as long as you've been a member for more than 2 years, like we did before, and you have a nodding acquaintance with Excel, come and see me at the break, and I'll tell you a little bit more about what's involved in the role of treasurer. Those on Zoom, I guess they're still there. Go ahead and send me an email. And we have more openings coming up. And so all you have to do is watch for the announcements in the newsletter coming out, the August newsletter coming out at the end of this week, and grab your opportunity to serve the club. We need you. Thank you.
Thank you, Marnie.
Let me work this back.
Thank you. Okay, so we had sound coming out of two things. That was crazy. I have an ability to make things electronic dysfunction.
I just turned the sound off, so that's.
Yeah, so that should be fixed.
Okay.
Okay. Like last adjustment. Okay, good. Okay, yeah, so this is a better projector anyway. Okay. So as a reminder, as members, we are privileged to Mount Diablo's pristine location at the Lower Summit parking lot for our society nights. Nobody's allowed up there, so take advantage. Our next society night is Saturday, August 8th. Our next public observing night is Saturday, August 29th, sunset to moonrise. I don't see, is Ken here? No, okay, so I'm not sure if there, I know there's a Girl Scout public outreach, but I'm not sure public outreach, his needs, but that would be in the newsletter. Star parties coming up. We've got the Yosemite Star Party, August 7th to 8th. Scopes at Glacier Point. If you haven't already talked to Kevin Fairweather, I'm not sure if there's still availability, but make sure you email him, call him if you're not registered and you're interested in going. Barcroft is immediately following the 10th through the 15th. I hear they still have spots.
But
Okay.
it was due, the coordinator asked for everything
by yesterday. Okay, so if
get it to Barcroft, if he say astro.org like tonight, I will process it. But this is what you have to do, like fill out all the forms, it's a bunch involved, but I'll work with you because we do have a lot of empty beds.
Okay, so this year, yeah, so Barcroft is not sold out like typically. So this is Kathy. She's helping out with the East Bay Astronomical Society. Grab her at the end of the meeting if you're interested in going. I was able to go last year. We'll be in Spain for this one, so I'm going to miss out. But it is a wonderful experience and a little dizzying as well. And then CalSTARS down at Lake San Antonio is September 9th through the 13th. That one's pretty casual. You just have to pay the parks fee. You don't even have to RSVP. It's a lot of fun as well. Okay, and then this is Marty's shield. She already gave it, but we could really use some help, to keep providing the quality outreach, the public astronomy nights, the journal meetings. It takes a lot of work and coordination. It doesn't just work like magic. And in order to keep a club vibrant and going, always needing help from our members. So please grab me or Marnie after the meeting. Okay, so now we've got Kent with his What's Up.
All right. Now, back to the screen. There. Okay. This picture might look familiar to some of you. You saw it last month. This is James Webb view of the portion of the cosmos that has a very dense cluster of comets, not comets, excuse me, galaxies. It's called April 2742-4. And I just chose that as a background to start this. Now, a brief history of the first billion years of the universe. I'll explain that in a minute. Because a whole lot of stuff happened in that first billion years. NASA came up with a graphic that kind of shows phases of the development of the universe. I chose that as kind of a starting point, and I'm going to add some information to it. But this is what it looked like. It's got a very weird scale. If you can read the numbers, they're pretty small to you, I'm sure. It's not even logarithmic. It's hard to explain, but it's for what it's worth. I decided to use it. But we begin with cosmic inflation. What can happen in 10 to the minus 32 seconds? Well, the Big Bang, where mass began to move faster than the speed of light. That's this little, see if my pointer works, little pointy thing right here. That didn't last very long. As I said, 10 to the minus 32 seconds. In the first second, we developed a plasma, sometimes referred to as a quark soup or a quark gluon soup, because it takes gluons to make quarks stick together. But it's plasma. And it's just subatomic particles. And it's at 10 billion degrees Celsius. After about 3 minutes, we started to get what they refer to as nucleosynthesis. Actually, it started forming nuclei, not atoms, but nuclei. The quarks started to get together and form neutrons, protons. But it took about 3 minutes. Well, that lasted about 3 minutes, or was in the 3-minute period. And some of the earliest elements were formed: hydrogen and a little bit of helium. It was too hot for the nuclei to attract electrons, so we didn't have any atoms at this point. And so the universe was opaque at the time. At 380,000 years, we got a condition called recombination. The universe had cooled enough for electrons to be captured by the nuclei, and we started to get some transparency in the universe. And this was enough for light to escape. The formation of the atoms produced some light, a glow, if you will, because there were no stars yet. But we got from that the cosmic microwave background. Pay attention to that word, microwave. At this time, in the life of the birth of the universe, the dawn, it was actual light, had there been any human eyes to see it. But by the time we were able to see the universe through our own eyes, or photographs, the expansion of the universe had stretched the waves so much that they were down in the radio wave range, microwaves, and they were only detectable by radio telescopes. So we can't see them. This is false color. There is no color to it, but this is a attempt to show the various irregularities in it and the overall temperature of the what the light would have been like and what the microwaves are now. This is from the ESA Planck mission. But then we went into dark ages. From about 400,000, 400,000 to 600,000 years, hydrogen and surrounded it filled the universe pretty much, and the wavelength stars, excuse me, not stars. No, there were no stars as yet. The wavelengths didn't last, it didn't allow any light to pass through the, excuse me, the density of the gases. We didn't start getting the first stars until about 200 million years, 400 million years, that range. At first, the universe was just kind of lumpy and clumpy clouds of gas, mostly hydrogen. And those began to coalesce and ultimately produced some of the early stars. There's one type called a population 3 star. This is an artist's concept of it. We have no pictures of them. You can't see them, even with James Webb. So this is an artist's concept of it. They were very light, mostly hydrogen and helium, no heavy metals or anything like that yet, but they grew enormously. They could have a volume or size from about 30 to 300 of our suns in mass. They were huge, but they had short lives and produced a lot of supernovae. And that, in turn, would have given some light, but not much until we get to the epoch of reionization. The stars eventually, first of all, the stars were surrounded by hydrogen, a lot of hydrogen gas that was still kind of clouding the universe. But the stars began to produce ultraviolet light, and that UV started ionizing the hydrogen and clearing out the universe, and so the light could actually pass through. This was somewhere between the 600 million to 1.6 billion year range. You see, the scale here goes all the way out to today, 1.38 billion, excuse me. But despite all that, about 90% of the universe is hydrogen. And those are references that I used for developing this. Do I have any questions? Okay. Thank you. Yes.
How far back in that time sequence can James Webb actually see?
How far back?
How far back in time can the James telescope?
Well, the little red dots that Dr. I'm sorry, I forgot his name, spoke last month, are back in that same time frame, about 600 million to 1.6 billion years, roughly. But we don't know what they are yet. Still don't know. They're a mystery. There's a lot of speculation, but nobody knows for sure. They're still studying it. They're looking at other fields in the sky besides the field, that one that I showed in my opening slide, to see if there are more areas of dense galaxy collections that also reveal some of those little red dots. But it's up in the air right now.
All right, thank you so much, Kent. So Kent is our What's Up coordinator. So if you have an interest in anything astronomy related, and want to share it with the club. Remember, you can just email him, grab him after the meeting.
Beware, sometimes you get to do it yourself.
Yeah. Every 15-minute presentation in front of a really supportive and awesome audience. I've done a couple, and it's been really a rewarding experience for me.
I will
as well.
say this year has been really good for volunteers.
Yes. So thank you, everybody. All right, and thanks again, Kent. We're going to take a 10-minute break. Are there any new members in the room? Anybody's first time? Okay. Just as a reminder, restrooms are through the doors here, and we have snacks in the back. Okay, we'll see you in a few.
There's a lot of
Yeah, everything has to be off except for the video.
But when you want to play the sound, you'll mute yourself there.
Yeah, I think this is off.
Yes. Yeah. So you'll just hit right there on the side. So it's
That
like,
was this side.
yeah, and I'll come over. Hold on. Perfect. Okay.
Okay, so
These ones are also.
20 maybe years. Maybe on.
And I kind of balance it like over the dark. Yeah.
And maybe I'm not.
I thought it was 20,000.
Maybe an old number too. Because those numbers have changed. Anyway. Let's just take a look at the argument.
Yeah, I think maybe they find the right one.
And down dimension.
Yeah, that's the auroral.
But it was.
It's only. I thought it was only 200.
Those just got turned back on, yeah.
It's 100.
And it's made it.
Okay, who in the audience has ever witnessed the Northern Lights?
Sound is the same way.
Echoing again.
You're in a DK.
Okay, I'm gonna get away from the speaker. How's that? Oh, Marsha, is it your computer?
Yeah, I think so.
Yes. Okay, how's that? 3, 2, 1. 3, 2, 1. 3. Yeah, your computer is on. 3, 2, 1. Better? Okay. All right. Thank you, guys.
What did you change?
I unplugged her computer because she will need the auxiliary speaker for a part of her presentation. I don't know why it was just doing it there. Whatever. Okay, who here has seen the Aurora? Raise your hand. Okay, who was lucky enough to see it in California the last couple of years? Yeah. Okay, how about Iceland? Anybody Iceland? Alaska? Okay, and who thought it looked better in pictures? Okay. I did experience it once where it actually looked like in the pictures, and I literally fell to my knees crying. It was amazing. Okay, so our speaker from this evening, we've got Marsha Kirschbaum joining us. Marsha grew up in Anchorage, Alaska, and as a child, she sat outdoors and drew pictures of the stars and night sky. So later, during a photography workshop, she discovered that she could photograph the night sky and has continued to aim her camera skyward after the sun has set whenever she has the opportunity. While Marsha has had no formal photography training, she has benefited from the mentorships and teachings of friends and workshops. Her husband, Howard, a skilled photographer, has guided Marsha along in her photographic journey, and her picture of comet pan-stars was shortlisted in the 2013 Royal Observatory Greenwich Astronomy Photographer of the Year competition. In 2020, she self-published her book, A Cosmic Embrace, a Photographer's Communication with the Night Sky. Her night sky photography has been published in various issues of the Lenswork Publishing, Bay Nature Magazine, Marin Magazine, and most recently, the San Diego Magazine. She is currently a member of the Mount Diablo Astronomical Society, the Berkeley Climber Club, and the Rossmore Photography Club. So if everybody, can you please welcome Marsha? She's going to talk about Aurora, nature's amazing light show.
Well, thank you all for coming. I really appreciate it. Aurora is one of my favorite night sky light shows. I'm starting out with this slide because the Perseids meteor shower is coming up. And this aurora was taken during the Perseids meteor shower. And we were very fortunate that that happened. It's Lake Topaz. It's not Topaz, sorry, Lake Tenaya. So, yeah, this is my husband and I relaxing on top of Hawk Hill. And this is actually a title of a video that I did, Come Sit With Me Under the Stars. And with that really wonderful introduction that Tara did, I don't need to go too much into this, but I did want to explain that several of the slides in my slide pack were done by different photographers because I felt that they actually expressed the point that I was trying to make better than my images. So some of these are done by other people. So Aurora, what is it? Simply speaking, it's electrically charged particles from the sun called corona mass ejections, and a lot of times it's shortened to CMEs. And when they're directed earthward, they slam, depending upon their magnetism, into the Earth's magnetic field, and they excite oxygen and nitrogen atoms high up. And with these collisions, they give off a glow, and the shape of the glow is kind of mimics the wavy lines of the magnetic field. And this talk's going to focus mainly on my experience photographing auroras in Fairbanks, Alaska. That was the easiest place to get to, and a group of friends and I decided to go up there and aurora chase. So where and when to photograph the aurora? For consistently photographing them, you want to be in the more northern latitudes, closer to the Earth's magnetic poles. And because particularly strong, well, although particularly strong CMEs can actually penetrate the magnetic field and with a lot of energy travel a lot farther down, where you might see them in Northern California, Montana, the states kind of along the Canadian border. Although some of the storms that we had, particularly in 2024, those had so much energy behind them, they were seen in Mexico and just pretty much throughout the world. The best times to photograph are early September through mid-April. Where the northern latitudes actually start to get night skies. And September is a little bit warmer, and you have a better chance of seeing reflections by lakes that may have not frozen yet, or streams, which is kind of nice. The the lights from the aurora are so bright that you can get reflections. In the winter time, well, February and March, there's still snow on the ground. The trip that I went on was in March. And if you're lucky, you can get those snow-covered trees if the wind hasn't blown it off yet, which makes for a really nice foreground. It's still, March is definitely a little bit warmer than the dead of winter. And of course, you want clear, dark skies. And most of the activity, auroral activity, according to the NOAA Space Weather Prediction Center, happens between 10 and 2 a.m. And I have to say that our experience, we had an incredible night and morning of aurora, and we were leaving at 4:30 in the morning because we just couldn't keep our eyes open anymore, and the aurora was still going.
Do they happen in the southern pole?
Yes, they do. It's where the magnetic poles.
So it's not just the.
No, the CMEs, if they're at the right, and I'll explain some of the criteria that they need to be, but if they penetrate through the north latitude and they can follow along, here's your globe, and they can follow along down towards the pole, and they have so much energy, and I'm not sure, space weather is a real science that I'm not totally familiar, well, not familiar with at all. They will slingshot back, and you can get aurora during the southern poles too. So aurora color, this is dependent on how high the oxygen and nitrogen atoms are excited. And at 120 plus miles, you'll get your reds. And that is because the oxygen atoms, there's fewer of them up there at that height. And so they get a lot more energy when they travel before they collide with each other, and it throws off a red wavelength. The green colors are a little bit lower, 120 to 60 miles. And because they're more densely packed, being lower in the atmosphere, they don't get quite as much energy, and this gives off a green glow. And if you see a blue glow, those are from nitrogen atoms that are colliding. The pink are the lowest atoms, nitrogen atoms below 60 miles an hour, up 60 miles above the Earth. The red, when we see in California, many times we will see the red. It's because they are the highest up, and they can get kind of above our horizon line if the energy from the storm is, geomagnetic storm, is strong enough to send them up that high. And sometimes you get colors that will blend together to create other colors. And this orange color, I had never seen that before, but it did show up on my friends' cameras too. So I'm just thinking, I can see a little bit of red. I don't know, can you see my, yeah, I can see a little bit of red up here, and possibly that combined with some of the green to give us this sort of yellow color. And the color, a lot of people say, oh, well, you can't really see aurora. It's much brighter in the camera. The camera's not accurate. And basically, we see in the dark, in low light, our eyes see with rods, which do not see color. And bright light activates our cones in our eyes, which do see in color. So, if you see a really strong, what they call a substorm, and I'll explain about that later, where the colors are really bright and vivid, you will see more color. Sometimes if it's gentle, you see kind of what's on here on the left, and it looks a little bit faded. If you're not sure you are seeing aurora, either look through your camera or hold up your phone. the sensors do not have the same restrictions that our eyes do. And just take a quick photo and you'll see that whether it's aurora or just a misty cloud. Now I want to talk a little bit about the equipment that you might want to use to photograph the aurora. I don't think, you don't have to have a real fancy camera. Your mobile phones do a pretty good job of photographing the aurora. This here is courtesy of Karen Whitaker, who was on that trip with us. And we had already been up on a hillside. We had been photographing, for a couple of hours, and it was time to go home. It was well after midnight, after 1 o'clock in the morning. And so we're driving down the hill, and we're looking out the window, and all of a sudden we just see the sky start to whirl back and forth. Stop the car. Well, our fancy camera here was already packed. But Karen had out her phone and she got this video.
Knock it off.
So don't despair if you don't want to pack a lot of camera gear. You can use your phone. And so we really had, she was the smartest one of us, she and her friend, to hold up their phones while we're looking at our trunk and our gear that's already packed and going, oh man, I don't want to drag it out, it's cold out here.
Is there any sound?
Yes, well, there was the sound of us oohing and awing. But I'll turn that on for another time lapse that I have. So the Aurora photography equipment, as you saw, you can use a phone or DSLR or mirrorless. If you're going to use a phone for any length of time, I would put it on a tripod. For 5-10 seconds, you can probably hold it steady for that. But if you're going to go for like an hour, a half an hour, more than a couple of minutes, it would be helpful to have it on a tripod or to balance it someplace where it's solid. With the tripod, I went in March and it was pretty cold. And I wrapped my tripod in pipe insulators. And that's with a foam that goes around pipes to keep them from freezing. And, excuse me, this helped me to carry the tripod so that my hands didn't get really cold. And I had read somewhere, but I did not experience this myself, perhaps it wasn't cold enough, that carbon fiber tripods can get brittle when it's really cold, like sub-zero cold, 20 below, something like that. And the pipe insulators should protect it from that. Fortunately, we did not encounter that kind of situation. It got to about 9 degrees, I think, when we were photographing. So the other thing you want is a fast, wide lens, 1.4 to 2.8 aperture, 14 millimeters to 24 millimeters. And the reason why you went wide is because you want to get as much of the sky as possible, because you don't want to miss any of that aurora as it fills up the whole sky. Also, you can use a shorter speed if you've got more light coming in, shorter exposure time, so 1.4, 2.8. If you're going to do a time lapse, you want an intervalometer or some type of remote. And I used a wired remote. And I will say that with that cold, that wire got pretty stiff. And so I was careful as I moved it around because I didn't want to break anything in it. Extra batteries, which you would keep next to your body to keep them warm. Frankly, my camera, which was a Sony a7R II, which eats batteries on a normal day, in the cold, it lasted for about 15 minutes. And it was very frustrating when I'd be getting ready and the sky is just blowing up and I get battery exhausted. So I had a battery pack. I usually carry those around with me, and I plugged my camera into a battery pack. And you can see these lovely hiking socks on either side of my tripod. These are my battery pack holders. They pack small. And I just wrapped them around with Velcro. And I had my battery pack on one side, and then I had my intervalometer on the other, and I had hand warmers in with them. Because one of the things that happens with LCDs when they get really, really cold is they go black. So you have to look through your viewfinder instead of back at the LCD. And, the camera, you can look through the viewfinder with your remote, a wired remote, and that LCD goes black. You can't see to change any of your settings. So that's why I kept hand warmers with both the remote and the battery pack, and I found that worked fairly well. You want extra cards, particularly if you are going to photograph with doing a time lapse. I did not, but I can see where we really, you take pictures one after another, and you can use up a card really quickly. And a headlamp with a red light, and I'll talk more about red light as photographing with landscape. For the cold, I used a plastic bag, a 6-gallon plastic bag, and some large desiccates. They were about 5 inches by 3 inches. And when I was done for the night, I would throw my camera in that plastic bag with the desiccate. And that was to prevent the condensation from forming inside the lens and inside the camera as you brought it from the cold into a warm area. And so I would also put it in my camera bag when I was done, in its plastic bag with its desiccate, and I never had any trouble. When I got to the hotel room, I would just quickly take out the card and then put it all back. And that kept the camera nice and cold pretty much until I was ready to use it again the next night. I talked about hand warmers. If you're going to go in September where you're going to have running water or a lake, because you want to get those starry reflections in Aurora in the lake, you might want to consider a dew heater because of the moisture. You do not want to get frost on your lens. It takes a long time to get it gently off, and you certainly don't want to scratch your lens trying to rub it off. And whatever you do, don't breathe on your lens and don't breathe on your viewfinder. Otherwise, that gets frosted too. And feel free to stop me and ask questions if you have. So the red light courtesies. Most of the time when we're doing astrophotography, we're looking straight up. We're not trying to photograph anything on the ground. But with astro landscape photography, you have a lot of land or something in the foreground that is earthbound. So you've got to be careful with your red light, particularly in the snow, because the snow really reflects the light. So if you're going to use a red light, and that will definitely save your eyes, use a pen light and put a snoot on it so that you can guide the light to whatever dial you're trying to look for on your camera, whatever you're trying to do. And you can see this woman here, she has a snoot on her light so that there's no trespass light trespass to the other photographers. And you can also see the slight green on the snow as a reflection from the aurora. You also want to tape over any lights on the camera or the intervalometer to prevent light trespass. And I know it sounds like, well, that's such a tiny light, but it's amazing what your camera sensor will pick up. And it's really hard to get red light out of post-processing. So camera settings. You want to shoot in RAW. JPEGs just don't give you enough data for processing and for all the finer points of the Aurora, or actually for any landscape picture for that matter. Turn off the noise reduction. Noise reduction in camera, basically what it does is it takes a dark frame, the exact same exposure time as your light frame was. Now, 6 seconds doesn't sound like much, or 25 seconds, but while you're waiting there, you can't take a picture. And if something is really happening in the sky, you won't be able to capture it because your camera is busy doing dark frames. If you're on a tripod, turn off the in-camera anti-vibration. Otherwise, it tries to compensate and you can get your pictures a little bit blurry. Want to shoot in aperture priority, which is, and I use the widest, you want to use the widest aperture setting that your lens will allow. So pretty much I set it for 2.8. That was as wide as my lens would go. And then that way you can just adjust with the EV. And that is an exposure value. And basically when you turn it up or turn it down, it will compensate either with ISO or shutter speed to capture what you want at that aperture at 2.8. And it's only one thing you have to turn instead of fiddling around with the ISO and then fiddling around with shutter speed. You can just adjust it back and forth like that. So it's only one thing. And when you've got really heavy gloves on, you don't want to be trying to fiddle around with a bunch of different settings on your camera because your fingers will get cold. And I actually had a friend who was recently up there during a really cold time, and his fingers got frostbitten. They sent him back. They got frostbitten enough and needed medical treatment. Manual focus. It's very hard to do autofocus on a very moving light. And what I usually do is I focus for the stars because I'm shooting at a really wide angle, like 14 millimeter. And with 14 millimeter, it's got a wide focal length so that if you're shooting something in the foreground, you're more likely to get it in focus together behind it with infinity. If you got something really close up, then you need to deal with what they call a hyperfocal distance. And that is something that you would better to test in daylight and warm weather. And that is where your foreground subject is in focus and everything behind it is in focus to infinity. And you need to know how far away that is if you're going to try and get, you know, say a tree that's right close up and then get the aurora in focus. Blinkies, if your camera has blinkies that tell you if you're overexposing, that's really important because the aurora can change brightness so quickly. So you want to check that histogram too. And after you do this, you know, a couple of times, you'll kind of get the feeling for how bright something is, when to dial back, or when, if it's too dark, after you've checked, then maybe take your EV up one notch. Use an ISO that allows you fast shutter speeds. In my case, I use 6400. I couldn't go any higher than that for this camera because it gets pretty noisy. But the cameras nowadays, you can go up to 6400 and get a good, good data in the file. And the noise reduction in software these days is so good that you can take care of that in post if your image is slightly noisy. In a weak aurora, I exposed anywhere from 10 to 15 seconds at ISO 6400, 2.8 aperture. Strong aurora, anywhere from 3 seconds to 9, 10 seconds. And the white balance, you want to turn off auto because especially if you're doing a time lapse, you want a consistent white balance going all the way across. And you can kind of test that white balance to see if you're getting, when you take a picture, if you're getting the aurora color like you like it or like it's supposed to be. So I'm going to show some pictures here that show the various settings that I did, and some of them are mistakes. They'll show you what it looks like when you don't get the settings just quite right. The one on the left here, I don't know what I was thinking. It was 25 seconds, and you can see there's no detail. You can't see the waves in the aurora. It's just kind of a green smudge. So this is the same, looking in the same direction. The aurora has blown up a little bit. There was a substorm, and I went down to 6 seconds. I probably could have gone down to 5 seconds, but you can see that it's got much more detail than this one does. This one on the left, 5 seconds, and this is a corona, which is where the aurora substorm happens right above you. Corona, I think, is Latin for crown, and it does. It just envelops you. You're surrounded by light. It's just awesome and amazing. In the picture on the right, I went up to 8 seconds because you can see there's a cloud cover here. And I felt like if I exposed longer that I might be able to penetrate that cloud cover. And it did penetrate it a little bit, but then I lost some of the detail in some of the aurora here. But it reminds me of an angel. And this is an aurora, what I call a gentle aurora. There were clouds coming in. You can see them towards the base of the horizon. And so I did a pretty long exposure, 15 seconds. And I actually like the way it gives a sense of motion in that delicate green. That's Jupiter in the middle there. And you can see how reflective the snow is. It's like green. Same color as the aurora. Okay, here we have a substorm, and the aurora just kind of blew up. And what a substorm is, it's like a brilliant explosion of color caused by magnetic energy. In other words, the storm, the magnetic energy has really pierced Earth's magnetic energy, and it creates a very strong storm with all this light. You can see the reds and the greens, and it went so quickly from hardly anything to this that I almost got overexposed. You can see it's kind of white here. And this is just maybe a few seconds later that I took this picture. And because I didn't want to overexpose, I actually brought the aperture up to 3.2 and did it in 5 seconds. I call this a cosmic tap on Earth's shoulder because it looks like this giant vacuum cleaner is coming down. And here the aurora is starting to fade a little bit, and the clouds are also starting to come in. And so I did this at 4 seconds, and I went back to 2.8. And this is in a different area, and we're just starting to get another substorm where you can see all the colors. And 6 seconds, but you can see here the aurora is just a little bit blurred. Here's a little bit more in detail. And as you go through the Aurora photography experience, you'll start to find what settings are going to work for what energy the Aurora has, how quickly it's moving. And if I knew how to do my notes at the same time, I wouldn't be flipping all these pages. So on the left, this was a corona which came overhead, and you'll see blue, which is nitrogen. And I am told that it's kind of, you'll see that more often when it's getting towards dawn. And this was one of these nights, mornings, where we were up. This was taken at 4:40 in the morning. And the sky, it was still astronomical dark, but it was starting to lighten. And this is another corona. And then another one here, and you can actually see the Big Dipper. And then there's the North Star. So when you're going out to look for aurora, you want to look north, start with north. And if you think it's going to come into California, and we'll talk a little bit about how strong it might need to be shown in California, you're going to want to look north, because that's where it's going to show, if it's going to show at all. Okay, forecasting the aurora. This is a deep dive into science, not for me, but it's fascinating on what the space meteorologists go through and the data that they look at to see if an aurora is going to be blowing up anywhere in Earth. And there are apps that sort of distill all of this. And while I have to admit, while I was up in Alaska, I really didn't understand much of this, but I was very fortunate to be with people that did. And I went with a tour, and the husband-wife team, and the wife, she had all of these computers that were hooked up to satellites, and she could tell me when, look up in an hour, and she would remind us. But these are the main things that I look at to determine whether or not there's a likelihood of aurora. A lot of people say, oh, KP index, you need a high KP index. Well, that definitely helps, but that's not true. And a KP index is sort of an average of magnetometer readings from various stations that are set up in the northern latitude. And they use that to make the ovation model, and I'll show you. I know you all have probably seen that. I will show you a picture of that in the next slide. And then the solar wind. Typically, it's about 300 to 400 kilometers per second. The solar wind gives energy to the CME, and when you get a really fast solar wind and a bump in plasma density, because that's what's actually coming towards you is plasma, it gives a lot of energy in order to break Earth's magnetic field. But the BZ index, which is an index that measures the plasma magnetism, to me, that is one of the most important things. And it really caught my mind when I was up in Alaska. You want a negative BZ measurement, because Earth's magnetism is positive. And so if you think of it like two magnets, if you've both got the same magnetism, it repels each other. But if you've got a negative and a positive, they slam together. And that's what you want to penetrate Earth's magnetosphere. So whenever you see a measurement of that BV index and it drops south, it drops below neutral, that is a really good indication, especially with high solar winds, that we might have an aurora. So this is the elevation model, and this shows up in a lot of forecasting. And the green is, aurora. You probably see aurora. The red is definitely aurora, and you can see Fairbanks is right up here near the red. So it's a good place to go for aurora if you don't feel like flying to Iceland or some other place up north. And it combines the solar wind measurements and Earth's magnetic field strength to give us sort of a one-stop graph. What I find of interest is this red line down here, and this is called the view line. And supposedly, if your state or your location is within that view line, you may be able to see aurora. And you want to look north if you're in that view line, just to make sure. This is a part of a BZ graph, and because this is a screen grab, I kind of took it on a day where there wasn't much happening. It's January 3rd, 2025. And if you notice, the time is in UTC, and much of these forecasting information data is in UTC. So you've got to subtract hours from the location that you're at. And I think for California, it's 8 hours and maybe 7 hours with daylight savings time. But you can see here where the BZ actually went negative, and over here it went more negative. And so that would give you a much more likely chance that you would see an aurora with a higher KP index and a really strong solar winds. This is one of my favorite graphs, and this kind of gives you a visual picture of how the CME leaves the sun, goes past a satellite, which is called stereo A. There used to be a stereo B, but it quit working and they finally decommissioned it. But what the satellite does is it measures the magnetic field, a plus or minus magnetic field. And this is Earth here, this little green dot, and this is the satellite. And this will play in a time, and it will give you the density, plasma density, as it goes through time. And this is the magnetism. And here is the wind, the solar wind. Stereo A will tell you how many kilometers per second. So if all works, I am going to play this next one for you so you can see how it actually goes. And you can find this on the Space Weather Prediction Center for NOAA. So watch how there's going to be a CME that's thrown off right here, and it's moving towards Earth, but it's only kind of a sideways glance, so we may not get so much of that. And you can see green here. There's not a very strong solar wind. Orange is much stronger. We're kind of in the green and the blue. So not sure, given this, that I would expect too much in the way of aurora. Okay, this is, I thought it would be kind of fun to see what the data was for the aurora that made it as far as California. And there is an archive that you can look at that you put in a date and time, and it will give you the measurements. So I went back over some of these pictures that I took. This one I took from my deck in Oakland. And you can see I'm in a suburban neighborhood. There's lots of light. I was actually kind of looking for Aurora, and I happened to be in Walnut Creek at the time, and I kept looking north, didn't see anything. By the time I got home, I saw these like pillar-like clouds, and I'm going, huh. So I grabbed my camera and I held it up and I went, oh my God. And I got my husband out of bed and I said, you've got to come out here and look at this. And sure enough, here was the Aurora, and it was so strong that you could actually see a little bit of green that got pushed up. And this particular night had a KP index from 8 to 9. The BZ, which is the north-south orientation of magnetism, it was minus 49 NT. And I don't know exactly what NT stands for, but that is a measurement that they use with magnetism. Anyway, that was quite a southward drop. And the wind...
Nanoteslas.
Pardon?
Nanoteslas.
Oh, okay. Well, I still don't know what that is, but it's nice to know what it stands for. And the solar wind at this time was 789 kilometers per second, and it was designated as a G4 storm. And this particular storm actually interfered with a lot of equipment that depended on satellite. The magnetism interfered with that. This one here was taken at Lake Tenaya Lake. I was up there for the meteor shower, which you saw in that first image before I started. And I knew that there was some possibility for auroral activity, but frankly, I was more interested in the Perseids at the moment. I didn't think, I mean, who would think that you would get in California 2 aurora displays in the same year? However, I was checking, I had 2 cameras set up. One was looking north, and this was looking more northeast. And I checked my camera on the north, and I'm seeing kind of pillars. And so I took a picture, and I went, oh my God, there's Aurora out there. And it was absolutely beautiful. And it reflected in the lake, and it was awesome. And that that was also classified as a G4 magnetic storm, had a KP index of 8 and a BZ of minus 14. The solar wind was 510 kilometers per second. Again, the same lake, and this time I got a Perseid meteor. So this was like a double whammy, Aurora and Perseid. Yep. And here, the Aurora is much more pink, probably because it is nitrogen atoms. And boy, that year was a big year for Aurora. October 7th, I was down in McClure's Beach in Point Reyes. I had my big camera on a tracker. I was going after the Lagoon Nebula. And I turned around because it gets kind of boring while you're standing there and it's tracking. And I saw these pillars here, and I go, huh, that looks like Aurora. So I held up my phone, and I went, sure enough. So I took this shot, and what's kind of special about this shot is that this is a SAR, which is this kind of red curve arc here. And that's called a stable aurora red arc. And I'd never seen one of those before, but I was happy to photograph it. And here we are again, October 10th, 2024. I mean, 2024 was a really big year for Aurora. Now this is taken in the moonlight. And this is a G4 magnetic storm and KP8. And I took this with the iPhone. And then this was taken on November 11th, 2025. And again, from my deck in my old house. And it was funny, it was like I was moving that night or that morning. I was out of the house, it had been sold. And I thought, wow, what a gift. And this was a KP8 storm. The BZ was minus 64. And the solar window was only 296 kilometers per second. And I think because the BZ, this is in my uneducated opinion, that the BZ, because it was a minus 64, it was powerful enough even to compensate for that solar wind to punch through Earth's magnetosphere. Okay, getting towards the end here. You guys have been really patient. These are some links for Aurora education and forecasting. Vincent Ladina, the Aurora guy, and I think he spoke at one of the astronomy clubs. He's really, really good. And if you go to his website and you get past all the tours, he's got a lot of articles on how to see specific things in the aurora, how to forecast, what a substorm is. I mean, you can really take a deep dive into all things that make up aurora. And if you get on his mailing list, he will also send you an alert for aurora, although it may not necessarily be as far down as California. Space Weather Live is where there's an archive. So if you want to look up a past aurora and kind of see what the data is, you can do that. And then the NOAA Space Weather Prediction Center has really good aurora tutorials. And aurorasource.org is kind of an interesting website. It's got a lot of tutorial information, but it's a community-based website. So people from all over the world report what they see and will post pictures. For forecasting, Tara recommended this one, and I absolutely love it. It's called the Glendale app, but it's not really an app that you can get through the app stores. It's on a website, and it's free, and it gives probably the best information all in one spot, graphically easy to read, and it comes in the time zone that you are located in. So no more of that subtracting. Of course, the Space Weather Prediction Center has the Aurora dashboard, and it has a lot of graphs and charts that you can also look at. And Space Weather Live, the same. Spaceweather.com, also the same. And one of the things I really enjoy is the solarham.com, because that gives you a lot of information that is sun-based, like the sunspots, if they erupt. Are they sending out solar flares only, or are they going to send out a CME? Oh, by the way, a solar flare is not the same as a CME. A solar flare is light and travels at the speed of light. The CME is plasma, and that's the stuff you see around an eclipse, a solar eclipse, and you will see the plasma feathering away from the dark area. Also, Amazing Aurora is another good one that gives forecasts in the time zone that you're in. And these can be used on phone or desktop. The CME scoreboard by the NASA Community Coordinated Modeling Center is really interesting, but it's a deep dive because it's mainly for scientists, and they kind of report scientifically on what they're seeing, what they think the measurements are, et cetera. And it's kind of fun to look at. This is a really good ebook that on how to photograph the Northern Lights. This is author is Patrick Endress, and he lives in Alaska, and he co-authored with another scientist. And a lot of that information I used when going up to Alaska and photographing the aurora for the first time. Okay, this is where I need help. This is photographed by Rick Whitaker. It's a time lapse, And this is for the 7 nights that we were actually in Fairbanks area, and we saw Aurora every single night. And in addition to his still cameras, he set up one to take time lapse. Oh yeah, I've got to turn that off. I get goosebumps every time I see this.
What was that called again? Can you repeat the title of that?
7 nights in of Aurora, 7 nights of Aurora.
And that can be found on YouTube?
No, it's his Vimeo. If you look up Rick Whitaker, you'll see all of his Vimeo. He does a lot of time lapses, and he's got some really good ones. Also, a shameless plug for him. If anybody wants to learn how to photograph the Milky Way or star trails in an absolutely wonderful venue, he is giving a workshop on that through the Ansel Adams Gallery in Yosemite. It's a 4-day workshop. He's been kind of like a mentor to me. Anyway, we're just about done here, but I wanted to go over some odds and ends. Particularly if you're going up in the wintertime in March like we did, it's very cold. It's tempting to try and find a bunch of warm weather gear to pack in your suitcase, and then you have no room for anything else. The good news is that you can actually rent clothes in Fairbanks. Yes, that for like a set fee, they will give you a bib, really warm bib, bunny boots, which is what the same boots that the military wears to keep warm, a down jacket that is like the 850 pile. It's like an Arctic jacket. The only thing I rented extra were a pair of down gloves, and I wore a pair of merino wool. Well, they were down mittens, and I wore a pair of merino wool gloves underneath those so that I could quickly figure out a camera setting if I had to. And I had hand warmers in there too. If it's the first time you're in an area, I would highly recommend going with a tour agency, one that specializes in photography. We went with a group called Aurora Chasers for 3 nights, and then 2 nights we were on our own. But the Aurora Chasers, they made it so easy. They came and picked us up at our hotel room in a van, and they gave sort of tutorial on how camera settings and what you expect to see, and a little bit about forecasting. That's where I learned about the BZ index. And based upon that forecasting and weather forecasting, they would drive us out to areas beyond the clouds. And then they would say, okay, you know, in an hour, you're going to see a substorm. And basically, they had gotten the information from the GOES satellite or stereo A. And it takes, when that gets the magnetism, measures the magnetism, it takes about anywhere from an hour to 90 minutes to reach Earth. And so you can kind of plan for that. And the first time you're out there, you're trying to figure out where you put your battery in these new clothes and how to fumble with your camera set. There's a lot of distractions, plus the fact that it's cold. So I recommend that if you do this, you do at least 2 nights, because the first night is like kind of breaking in, which is not to say you won't get some really nice pictures if you're after pictures. But the second night, you're more at home. You know what you want to do with your camera. You're used to moving around in these clothes and where you put stuff. It's kind of like going camping and trying to find everything that you've thrown into a bag. And in the daytime, I recommend, particularly in March, to take tracks, which are like mini chains that you put on your shoes. And they're really good for when you're going in and out of buildings, because the warm air from the buildings has a tendency to melt the snow, or the sun on the street will melt the snow, and then it starts to freeze, or it's got a little layer of ice underneath. And this really helped me from slipping. So I highly recommend those. So that's kind of about it. You can see what happy campers we are here. It was a wonderful trip. So if there's any questions.
Amazing presentation, Marsha. Thank you so much. I guess my first question would be for any members that are planning on a Northern Lights trip or tour, is there a certain time of year you recommend going, given the current solar cycle?
Oh, the solar cycle, like this was supposed to be a year where it was going down, and they've already had some G-force. I mean, just in July 3rd and 4th, they had a magnetic storm that could be seen in Oregon, as far south as Oregon. So you kind of want to go at a time where you've got dark skies. The farther north latitude that you're in, the better chance you're going to that you will see aurora, but you need those dark skies. And so if you're up north, that's going to be in February, March, or September through November, etc. Before it gets too cold. Dead of winter can be really, really cold, really, really dark and clear. But
if I can add on to that, in February, they have the International Ice Sculpture Competition in Fairbanks.
They do.
It's incredible art, and it fits a good time to look for the lights as well.
Yes, it was there in March too, when we were there. It was there, and it's fantastic.
Got a question over here.
Yeah, just I didn't see wildlife in any of your kind of the nightscapes that you had, but was there any wildlife? And actually, my big question is, if you did see them, did they ever react to what's going on in the sky?
I did not see any wildlife. No, I didn't. When I was growing up in Anchorage, there were like snow hares and things like that, and moose, but didn't see too much wildlife in the wintertime.
Okay. Any other questions for Marsha? Okay, just a couple of quick announcements. Rich Ozer is presenting for EAS this Saturday at 1:30 p.m. at Chabot Space and Science Center. He's giving a talk on the transit telescope. So I hope you guys can go to that and support him. So thank you for the heads up on that, Kathy. And also a very long shot, but for anybody that's interested, the Falcon 9 upper stage is due to hit the moon on August 4th. It'll be at a whopping 3.5 degrees for us at 11:30 p.m. But it might be a fun, impromptu society night for anybody that really wants to give that a go. You'll definitely want to be somewhere with a clear negative horizon. That will be August 4th. At 11:30 p.m. at 3.5 degrees. Oh, and Rich is speaking this Saturday at Chabot at 1:30.
This Saturday?
Okay. All right. Anything else before we go? Any announcements? All right. We'll see you next month and see you on the mountain. Thanks for coming, guys.
Thank you all for coming.
Thank you for the wonderful talk.
No, thank you.
Appreciate it.
Yeah,
Thank you.
you're welcome.
It's fine. I'm not into photography, I just wanted to see
The Aurora, yeah.
right, the Aurora, and we went up early October.
Uh-huh.
Yeah, it was early October, and it was cloudy every night. We went to Chena Hot Springs.
Oh, I know exactly where
Yeah,
that is.
That seemed like
Yeah.
that would be a good place to start.
It would be.
Yeah.
Yeah, you got to take a look at the weather, and you can't, there were a couple of times. Oh,
I think it's
yeah,
sounded like it.
yeah, I think you're right.
Or you could just take that off and not wear. Yeah, I guess that's